behalf of Department of Civil Engineering, KPR Institute of Engineering and Technology, in association with Institute of Engineers India Coimbatore Local Center, I welcome you all for this monthly lecture meeting and also Tech Webinar Series 17. Today we are going to deal about climate change and challenges. Our chief guest is Dr. S.R. Ramanan sir. Now I welcome Dr. P.R. Nadarajan sir, Chairman IEI Coimbatore Local Center, to give the welcome address for the gathering.
Thank you, Dr. Priya. Good evening, my dear friends. On behalf of the Institution of Engineers India, Coimbatore Local Center, and Department of Civil Engineering, KPR Institute of Engineering and Technology, I extend a hearty welcome to our chief guest, Dr. S.R. Ramanan, former Director, Area Cyclone Warning Center, Chennai, who will be today speaking on climate change and challenges. I also welcome our executive committee members and the members of the Institution of Engineers India, faculty members of the college, students of the college, and others. Once again, welcoming all of you to this monthly lecture meeting. Let me conclude a vote of thanks. Thank you.
Thank you, sir. Now I request Dr. G. Anusha, Professor and Head, Department of Civil Engineering, KPR Institute of Engineering and Technology, Coimbatore, to give the presidential address.
Good evening, all. I'm happy to welcome Dr. Ramanan. I would like to join with Dr. Nadarajan and Priya to welcome you, sir. We are having him in our institute for a second time. Last time we were happy with this lecture. We were very much impressed, and so we wanted to have his talk once more. I welcome you on behalf of our institute and IEI chapter. I also welcome all other members of IEI and student participants and other participants. I wish you all a very happy Teachers' Day on this wonderful occasion. As we all know, teaching is the only profession that creates all other profession. And today's topic is climate change and challenges. The climate change is mainly caused due to the pollution, especially air pollution. So as teacher, we are responsible in educating our students and also the public to avoid the pollution to some extent so that we can avoid the drastic changes and drastic damages due to climate change. And we are all waiting for Dr. Ramanan sir's speech. So I would like to conclude by welcoming you all once again. Thank you.
Thank you, ma'am. I'm very proud to introduce our guest, Dr. S.R. Ramanan sir. He is a meteorologist from Tamil Nadu and official of the Regional Meteorological Department, has acquired celebrity status soon after his weather prediction after rains in Chennai came true in 2015 December. One of the popular heroes of Tamilians, he got nicknames like Rain God, Chennai Weatherman, etc., and also achieved a cult hero status within a short interval of time. Meteorological department officials do not have a favorable public image when it comes to their weather predictions, but when Tamil Nadu recovered from the worst rains in a century, the state's meteorological department is basking in a glow of admiration, and one meteorological department official in particular has become something of a cult figure in Chennai, and is none other than S.R. Ramanan sir. After completing his master's degree in Annamalai University, he received his PhD from Madras University in the field of agricultural climatology. He joined the Meteorological Department of India in 1980. He worked as a forecaster in Delhi in the earlier years and later worked at Meteorological Office of Chennai Airport. He became the director in the year 2002. He later joined Area Cyclone Warning Center at the Regional Meteorological Center at Chennai and retired as its director in 2016, soon after his flood prediction. He had a career spanning of 3 decades in this field. He has been appearing on television channels since 2002 to deliver weather forecasting. He came to spotlight during Chennai floods in 2015, 7 to 8 months prior to his retirement. Ramanan sir predicted about Chennai floods in the early November, and after his warning, the state government decided to close schools, colleges for 2 weeks and also postpone many exams. It helped to save the lives of thousands from the calamities of flood. Rainman Ramanan, word of rain, god of students, Malayin Mahatma, Kadalora Makkal Kadavul, and Minnal in Janal are among the names which Tamilians fondly used to address him later. Ramanan retired and after 36 years of service as a weatherman. With this brief intro, I now call upon Dr. S.R. Ramanan sir to take over the session. Please, sir.
Thank you. So, good evening to all who are there. I once again thank the Institution of Engineers Compensated Chapter for giving an opportunity to address you all, and also the KPR's management, their staff, especially HOD, Civil, Priya Madam, everybody, for facilitating this same. Now I'm just going to talk about what is climate change and the challenges. So, next slide. So the thing is, if I say winter is cold and summer is hot, then it becomes a wonderful accurate forecast. At the same time, we can also create a havoc in people's mind. Today it will be 98, tomorrow 137, and 209, fire, die, like that. We don't want to create sensationalism. People should take it at their own pace. No need for sensationalizing as far as weather is concerned. That's much more important. That's very important. Then only they will be able to withstand any disaster that may be associated with the weather as well as climate. Now, as far as the climate change is concerned, this is the top and global warming and urbanization. As far as air pollution is concerned, it is not having much impact as far as the climate change is concerned. Well, pollution can pollute the atmosphere and you will find it extremely difficult to breathe also. So in that scenario, well, it can affect our health also. It can even lead to some disease like bronchitis or lungs related diseases. So in that scenario, what to do? If a river is having lot of impurities and if it is polluted, we can stop the river flow, we can cleanse it, and again the river can start flowing afterwards. Well, in air it's not possible. How to stop? We can't stop the air. So only what we should do is locate the place where this pollution emanates. So it is incumbent on the inspector of factories to locate the factory which is giving out this polluted air and ask them to take corrective steps. Either she should change the technology or the factory should be relocated elsewhere and things have to be done in a proper way. So that's as far as the air pollution is concerned. I'm not going beyond that. Now global warming. What exactly is global warming? That we will see. Sun is next slide. Earth is not heated by the direct sunlight. It is the re-radiation from the Earth which is atmosphere. Earth receives the solar radiation, the shortwave radiation, absorbs it and radiates back towards the sky as a long wave radiation. This long wave radiation is trapped by some of the gases in the atmosphere, namely oxygen, carbon dioxide, ozone, like that. So these are responsible for heating the earth. Because of this trapping of the outgoing long wave radiation, the normal temperature hovers around 15. Had there not been these gases, well, this outgoing long wave radiation would have reached the space and Earth would have been cooler. I told something around 15, the temperature. Had it not been for these gases, if the gases are not there, well, the temperature of the earth would have been something around, say, -6, something around 21 degrees less. In that scenario, what type of life would have thrived on earth, I don't know. Well, this type of the phenomena by which the outgoing long-wave radiation is trapped is called the greenhouse effect. It is akin to what you can see in a botanical garden, these glass houses. What these glass houses do, whatever the sunlight comes, that is trapped because the glass acts as an insulator. Similar thing. That's why these gases which trap the radiation is called greenhouse gases. Well, things are wonderful. But due to industrial revolution, many gases, new gases have come, and some of the gases which are existing naturally, their quantum in parts per million, it has increased. As a result, much more trapping is taking place. So this is the reason why Earth is becoming warmer and warmer. So this is not a good scenario. This is a worrisome scenario. Why we are bothered? The question will come. See, if you take density, you take the density of water as 1. We have decided let it be fixed as 1, which is widely prevalent. And then we compare the densities of other materials in contrast to water. Then we say mercury is heavier, 13.6, osmium 15, something like that. They are very heavier. Then kerosene is light because it is able to float, something of density is 0.8. Similar way, if you see, take the trapping of the outgoing long-wave radiation of carbon dioxide as 1 unity, then you can compare the other gases. Methane, some 310 times, 29 times powerful in trapping the heat. Nitrous oxide, which is used as fertilizers, 310 times has the capacity to trap the heat. So that's why we read. Some of the gases are not existing at all. Due to the advent of industrial revolution, some of the gases like fluorofluorocarbons have come. So they trap much more heat. So next slide. In this slide you can see sulfur hexafluoride has 23,900 times the capacity of carbon dioxide to trap heat. So this is creating havoc. So we are really bothered. What we should do, we are thinking. So we have to find a solution. Either we have to control it. If we are not able to control it, we have to adjust with it. That we call adaptation. Of course, the best way is control. So how to go about it? What are the disastrous things we will get because of this heating? What are the challenges everybody will face? A lot of challenges are there. For few challenges, I will illustrate what is of interest to engineers also. I will tell something, 1 or 2. So, if you take, see from 1850 till date, how much it has increased. If you look, well, something around 1.5, like that it has increased. And this type of rate of increase, if fed into computer, different computers give a different type of scenario. Some computers say that by the end of the century it can reach around some 2-3 degrees more than the present value. Some even say even 7 degrees more, like that. If that is the scenario, then life will be very disastrous. It will be create havoc. Then how to go about it? This is the scenario. So in that scenario, then a lot of problems will crop up. But if you see the rate in which it has increased, only from 60s, the increase is much more. So how to go about it? That is the thing. Even if you take Chennai's temperature, max temperature is around 36. For example, I am telling. Well, say some 20-30 years back, it would have been 2 degrees less. The maximum temperature that day would have recorded only 34. Why? This is due to urbanization. So, increase in some of the gases like methane, carbon dioxide, this chlorofluorocarbon, all we call it global warming, and the denudation of the vegetation and replacement with buildings and all the associated activities, we call it urbanization. Increase in population, increase of vehicle population, lot of things are happening. So this has resulted in the increase in most of the cities. So this is urbanization. Both together is creating a scenario where the temperatures are bound to go high, up and up and up. So if you take India, 61 to 90, the temperature as India as a whole, the average if you work out is something around 24.6. Well, now it has increased to the tune of 1 degree, 0.913 degrees Celsius. Now it should be around 1. So now 1, okay, but in future, if it reaches much more, then it is really a worrisome scenario. But as far as rainfall is concerned, we are not finding it any regular pattern. Some years it is more, some years it is less. For example, if you take weather systems of Tamil Nadu, say it's a northeast monsoon, if the weather systems come to our coast, we are going to have more rain on that season, October, November, December, northeast monsoon. If they are not coming to our coast, less rain, that's all. So some years it will be more, some years it will be less. Why is less and more is some other topic. Anyhow, that is totally different. Anyhow, there is no pattern as such. Some years it will be more. For example, in 2015, the rainfall was something around 53% above normal for northeast monsoon. Whereas the next year, 2016, it was 67% below. It was a drought, severe drought scenario in Tamil Nadu. So such types of things happen. One year it will be more, another year it will be less. Seesaw things will be there. Well, again, let me come to the temperature. We say that there is a heat wave. How we say heat wave? See, every day for a particular day we have an average value, normal. So we have a 5-day normal in meteorology department. Pendant normal we say. We have 52 weeks in a year, 7 days if you take. So if you take 5 days, there are 73 5-day periods in a year. So 73 pentades. Each pentade is having an average value of temperature as rainfall, everything has been worked out. If that average value is compared with the actual temperature on that particular day, if it is say some 4 or 5 degrees above, well, we call it a hot day, heat wave is there. In few stations, if it is reported like that, something around 7 to 8 degrees is more in 2 or 3 stations in a particular meteorological subdivision, Tamil Nadu, Telangana, what tiles, water it may be. Then we say severe heat wave conditions are there. Well, this picture is illustrating that. If you take the decade 1971 to 1980, well, I have colored it green in say Odisha and on the coastal Andhra Pradesh because it has increased more than 15 minutes. We have colored it blue. So we had 21 days of heat wave in coastal Andhra and 18 days in Odisha. So 2 subdivisions were very bad. If you take the decade 81 to 90 on the right side, well, East Rajasthan and West Rajasthan are very bad. One had 16, another had 15. But if you take the next slide, 91 to 2000, you see, practically a good part of India is having a heat wave scenario. So that indicates a lot of heat wave incidents are occurring. Fortunately, some of the islands like Lakshadweep and Andaman, they don't have because they are all surrounded by sea. And also northeast states, they are having forests. So that's why they don't have much as far as the Arunachal Pradesh, Assam, Nagaland, Manipur, Mizoram are all concerned. Similarly, as far as the west coast is concerned, the winds are always coming from western direction during the summer period, from the Arabian Sea. So because it's a southwest monsoon period, I would have started. In April itself, the wind pattern would have reversed. So we get westerly winds. So it's from sea, we don't have much incidence as far as the Goa, Karnataka, Maharashtra is all concerned. So that's the reason. So other parts, it's all worrisome. So what are all the disaster effects, all these things we will see in subsequent slides. Even if you take the coldest place on earth, the Siberia is supposed to be the coldest place, you know, and you have a place called Verkhoyansk, which will have a temperature of something around minus 40 in winter. This Verkhoyansk recently experienced plus 40, 38 it is shown, almost you can take 40 if I take for approximation. So they were not knowing what to do in that scenario. Because they will not be having ACs in the house. They are not prepared for this type of scenario. So they had to go near fountains or water bodies to cool them down. And they had no other option other than that. Because they have not experienced such a thing. See, minus 80, 40 to plus 40, the variation is something around 80 degrees in Fahrenheit. Celsius. See? So this is the crux of the problem. So what are all the effects? We will see. Well, less snow and ice, and then animals' migration pattern can affect their life cycles, then rising sea levels, damaged coral reefs, like that, for a lot of things. Where it is bound to snow, you are going to have rainfall. Because the average temperature between the bottom of the cloud cover and the base is, if it is less than zero, only you will have rain, the snowfall. Otherwise, you will have only rain. So these type of things, droughts, all these things can come. So plants, lot of evaporation will be there, and we have to give water, much more water. These water shortages can occur. So a lot of disasters affect how to go about. One more thing, if it is snow, whatever incident solar radiation, shortwave radiation, 80% of it will be reflected back to the space. If it is water, it will not reflect, it will start absorbing. So those areas which are called permafrost areas, permanent frost areas, if they become watery, then it will be a disaster. Then what will happen? Lot of ice will melt and the level of the sea itself will increase. So these are all some of the things which we have to ponder upon. One more thing is, the cyclones form when the sea surface temperature is above 26.5 degrees Celsius. If the global warming comes up, the sea will be very hot. In that scenario, you will even get many super cyclones. In a cyclonic circulation, a tropic revolving storm, if the central place where we find the maximum wind, if it exceeds 63 kilometers per second, we call it a cyclone. And as the way it increases, the wind speed increases, we call it severe, very severe, extra severe, and all those things. And if it crosses 222 kilometers per hour, you call it a super cyclone. Many super cyclones can form. A lot of these things, some of the people who are doing research in this field.
Bom dia!
Well, so in this scenario, how to go about this thing?
Vou dar uma
Now, if
cagada
you
já
take
volto, hein?
the temperature pattern, next slide. Next slide. You see, it shows the increase in temperature.
Yes,
On the right
yes,
side.
yes. Okay. No.
So it shows increase in the quantum of heat content in the oceans. If the quantum of heat content is more, well, the cyclones can become stronger. That is the idea, the whole idea behind it. And how much the sea level has increased? in so many years. Something around 25 centimeters only, so far fine. Well, if you take the fresh water of the globe, only 3% of the fresh water we are having in the rivers. The remaining fresh water are in the cold northern pole or much more in the south pole, in Antarctic, in the ice sheets, the glaciers. They will all, if they melt, well, the sea levels can rise. The first places which will be affected by this effect of the sea level rise is some of the small islands, because they are all on coral reefs, like our Maldives in our neighborhood, and also some of the islands like Kiribati and all those things, because these islands are just over the sea. The natural formation will be few meters above the sea level, that's all. Practically the entire islands are just a meter or 1 meter above the sea. So they will all vanish. So it will ring alarm bells for us. Next will be some of the coast, including our coast, especially first will be Bangladesh and West Bengal coast. So they can have such problems. So next slide. So only these islands, they will be threatened. So what actions they have taken, we have to see. So Maldives, in fact, the capital is only 1 kilometer wide and 1.5 kilometers in length and breadth. They can't have a runway for a flight. A flight runway is around 4 kilometers. They have used steel and concrete. In fact, India has helped in constructing that airline, this runway. So after landing in the runway, we have to take another to the capital. Now they have taken lot of loan from China on Belt and Road Initiative. China has constructed the bridge from the airport to the town using billions of rupees. So that's they are of course also in a debt problem. Of course, there is a point aside. Then Mauritius, they have laid pebbles along the coast. Seychelles, what they did was they reclaimed some lands to sea. And then South Pacific, they thought there is no point in doing all these things because it's all costly proposition, building a wall or all these things. Best scenario is to go to other safe countries like Australia and New Zealand, they thought. So now, next slide. If you take the pictures, you can see the pebbles, I mean the stones laid along the Mauritius coast. So they have done like that. From the mountains which they are having, they have taken some rocks they have kept along the coast. And the next side, you can see a bridge constructed by the Chinese for connecting the capital Malé with the airport. And then below, if you see the pictures, the land reclamation done by the Seychelles, how they are doing it, you can see. So this some of the things. So next slide will go. We will see what Kiribati has done. See, it's just under this above sea. Now, a good part of where the houses were there, now it has become sea. They are really worried. Just to illustrate their point, they are all standing in water and they have sent the photographs. So they want to find it. In fact, Maldives conducted a few years back their cabinet meeting under the sea. So special clothes they wore and they conducted it. And what they wanted to show to the world, they are liable to be drowned in a scenario if Earth is not collectively acting. So everybody wants the Earth to collectively act and stop this rot. So it is incumbent on everybody, not to say government has to do and all, every individual has to do, that's all. So what we can do, all these things we have to see in the next thing. Well, we'll stop it like that, some countries thought. So when they had a tsunami also creates giant waves and water can come. So in Fukushima it happened, it affected even a atomic plant in that area. So what they did was they constructed a huge wall, tsunami wall. Whether we can construct a wall to protect it even if sea level rises. But they have a lot of problems because the visibility to sea was totally cut off. They were unhappy, some of the local people. Earlier we used to enjoy the sea, we can no longer see the sea like that they were telling. And another option is to mangroves also a good option. So mangroves if you grow, even if a tsunami wave comes, it can stop it and put brakes to it. And a combination of all these things should be there. So it should be cross-discipline approach. Like this agricultural people with the knowledge of how to grow these mangroves and engineers, civil engineers especially, all this we have to think what we should do. That's the thing. Next. So I am going to show what they did in Netherlands. In Holland, even when we are now not in a modern age, just before around Second World War, before that time, these Hollanders, Netherlands people did a wonderful job. What they did was they constructed a wall in the sea. Afterwards, between this wall and the original coast, you'll have definitely the water will be there. This water was pumped out to the other side of the wall. For that, they used windmills. Windmills they used to pump. And they strengthened the wall in some places. They even constructed a road on the wall itself. So it became strong. So such things are needed because when a tsunami wave comes, it will be 700 kilometers over. Such way will be the wave. So if a thick wall is there only, it is needed to protect us. And a cyclone, above again cyclone, again drowning by the sea, increasing sea level, and then tsunami, everything. We have to think an engineering solution. So it is a challenge for the engineers. Right now, today, all engineers should think, if this is a scenario, how to go about it, like that. See, even summer, we are having water problem. Due to global warming, the temperature rises up. The evaporation and evapotranspiration will be more. If the evaporation is more, how to save the water in the water body? So in Gujarat, what they did was they have put some solar panels. So the solar panels act it gives a shade so that not much water is evaporated, and solar panel also generates electricity. Otherwise, in some countries, they release lot of these balls protect from evapotranspiration. Now, as an engineer, you can think how to stop the evapotranspiration from the lakes. Had I been in your physical presence, I would have interacted with you and I would have got ideas from all of you to know how to stop evapotranspiration. Everybody will be having some idea, definitely. So it would have been a wonderful session had I been physically present there to interact with you directly. But through webinar, this is a problem. I cannot directly talk with you. Next. So, for adaptation and mitigation, you will see, increased energy efficiency. Everybody, we have to use CFL lamps. I am doing it in my house. Why not you? Like that I can ask. Because when I give lecture and all, I should practice it in my house. And then alternate fuels, natural gas, renewables, and nuclear. Nuclear people will say bad, but what to do? Once you put a switch, you want power in your house. No other option left. So we have to go. Through renewables, it can generate very good quantum of power, then it's fine. This is the thing. And then solar power, Japanese model, I will illustrate it with a picture subsequently. Because they generate power during the day with solar panel in the daytime, and they sell it to the Japanese electricity board. And night time they get the electricity from the Japanese electricity board and they are using it. The balance is taken into consideration, they pay. The net power they pay. So energy generated is saved is energy generated. So in our house or office, in another room where nobody is there, if power is there, you switch off. I went to the World Meteorological Organization building in Switzerland. They have kept motion sensors. Only when a man moves due to his motion, automatically the bulbs will glow, light. The moment he goes away, it will switch off. Probably you have to think that way. Then stringent industrial standards to curb pollution. That is much more important. So the best is to say clean technology. Suddenly you can't say one day you're polluting, get out and all. Then I will say what I will do for tomorrow for food. So we have to help him with a clean technology. So we have to do like that. And food security. Now, if much more evaporation takes place due to increased temperature, more water has to be given. If you are not able to give more water, it will be a stunted growth. So the natural vegetation growth will not be there in the crops. So it is incumbent on the agronomists to find out crops which demand less water and give more production like that. Then change in lifestyle, low carbon life cycle we have to. So in hot days we should not go out. Like that we should think how to manage it like that. Carpool is the best option. In a particular spot, if you are going, say from an apartment complex, people want to go to Avinasi Road. Some 4 people taking car from that apartment to the Avinasi Road is not a conducive thing. Vehicle population more, and then not of gas coming out, carbon dioxide, carbon monoxide from the vehicle will be more. So on a rotational basis, if 2 or 3 people share the car, one man driving and others from other apartment sharing the vehicle population will reduce. Well, that is a best solution. Lot of carpools are coming with apps, so we can contact them, we can join and we can do it. And then house itself eco-friendly. Houses, do you paint it terrace white, green building concept should come. So these are also a challenge for the engineers. So these are all challenges, and I am certain that they'll take it up as a challenge and find a amicable solution so that the world is saved. That is very important. So next slide. If we see the consumption pattern and all renewables and all I have given, now certainly our renewable energy source we have increased, no doubt about it. So 2018, which was around 69,000 megawatt, it has become 77,641. Well, it's a good thing. So much more has to be done. We can't rest on laurels. Lot more things has to be done. And then this side, you see, the solar power component is something around 95.5% of the total power consumption, and wind power is 10.2. Wind again depends on the wind. The wind speed is more, wind naturally coming itself is less, we can't do it. So solar is relatively much more dependable than wind, and then more solar power we have to do. That's the thing. And other ways in which we can increase, like biomass, we also should think of. And larger dams are bad, like what we are seeing in China, 3 gorges. So smaller hydro, smaller dams, wherever is possible, we can think of, and that can help us. And if we generate more power, and now forecasting has come, how much wind we will get in the next few days, how much solar we can get in the next few days, forecasting has come. So then we can correspondingly reduce the use of coal, and we need not release water also from the dam for electric power generation, so that we can conserve it for future. So to that extent also we can reduce the pollution, because the thermal coal power plants are the main culprits as far as the pollution is concerned. Next. So if I expose it to sunlight, how much is the surface? You see, it's 53 degrees. If the shading is 38, it shows. Similarly, zebra crossing, you see, something around 14 degrees Celsius difference is there. So the best solution is to paint the terrace white. All houses, the terrace should be painted white. And a cheap paint, or same time cost effective and easy to maintain. Like that, we should find a solution. So that is a chemical engineer's job. So everybody has to do something as far as these things are concerned. It is not only a particular discipline, it is a cross-discipline approach. It is an essential must in facing this scenario. So this is a Japanese household, you see. it's able to generate and give it to the electricity company. Again, there are some issues. Grid issues are there. If suddenly it stops, what will happen? It can create the system. Other house engineers are all working. A lot of using art all used. So every discipline, electrical engineer, electronics engineer, civil engineer, all people have to do. Scientists, everybody. So lot of things has to be done. So only if we do all these things, we can give a safe earth to our next generation. We have taken it as a loan from that generation. It is incumbent on us to cleanse this atmosphere, make it safe, and give it to the next generation. So everybody has to do our bit. With that, let me conclude, and if few questions are there, I am ready to answer. Whatever possible I know, I'll let me tell.
Sure, sir. Participant, do anyone have questions? You can unmute yourself and you can ask questions. Sir, we will wait for 2 minutes. Let participants ask questions.
Dear ma'am.
Oh,
Yes,
no,
sir.
Tell me, sir.
Yeah, sir.
Ma'am, if
No,
the students or faculty, if they want to ask any question, they can put in the chat box. So we can get
Yeah, sir.
Yes, sir.
Yeah,
Chat
sir.
box is ideal because I can see that in the chat box and immediately answer. That will be easier.
Sir, one question is asked by one participant like what has emission trading contributed to climate?
Emission trading is a different concept. See, what they do is, if some of the small industrialized countries, what they did was, they decided that they should reduce their pollution. If they are not able to reduce their pollution in their country, they can do a green project in some other country and escape from that problem of not reducing in their own country. This is called emission trading. Anyway, we should cleanse our house. That is much more important. Well, simultaneously help others also and involve yourself in green projects. That's the thing.
Do participants have any other questions? Sir, one more question. How can carbon dioxide emissions be compensated?
That is, we have to find an alternate technology, a carbon-free world. See, if you grow forests, it can sequester practically all the carbon. So, to that extent, you can mitigate that. So, likewise, we have to think, and whichever factory is emitting more carbon, we have to give an alternate technology. For example, if instead of from thermal power plant, if coal is good, use more renewable energy. To that extent, we can reduce the number of unit of coal is used for burning it. Likewise, we have to think. They are the best possible solutions.
Thank you, sir. Another question. How can we reduce melting of glaciers?
The melting of glacier, if we had to reduce, means we have to control the temperatures only. Only thing is, the greenhouse gases, if they are reduced, that is the only way in which we can reduce. Otherwise, no other option left. It's a very first factor. In fact, recently I went to Iceland. There, few years back, no glacier will fall into the sea. Icebergs will not be there in the sea. Nowadays, glaciers are melting and that ice sheet is coming to the sea. So it is a worrisome scenario. So somehow we have to, only way is a green technology is the best solution. Green technology means what? See, actually use, that is as far as the factory is concerned, carbon emission, methane emission, all these things should reduce. More forest should be there. If you take a forest cover, Tanzania, more than 40% of the land is forested. Forest cover is there. So likewise, forest cover is the best option. We should grow more forest. If you are having a city you are not able to grow, at least go terrace garden. Paint the terrace white. Like that, surrounding the house, don't have a cement floor. Instead, you have vegetation. So that even the rain falls onto the ground and goes to the earth. Like that, everywhere we have to do. Every person has to do. So that is the best solution to control the temperature.
Sir, one more question. What does mean by natural carbon cycle?
Natural carbon cycle is before the advent of this industrial revolution we had. But nowadays things are different. No? That's the thing. Going back to the original thing will be a bit difficult proposition. But yet, we will, as far as possible, we will try our level best.
Sir, what is the meaning of term sea acidification and how it differ from water pollution?
Acidification is acid rain probably is telling. See, every water drop if it has to form, it forms over a nuclei, a water-loving nuclei. Suppose a factory is emitting sulfur dioxide or like that, then it becomes a center of condensation and it becomes acid rain. Sulfuric acid will come. That's the thing.
Thank you, sir. I hope no other question from the participant end. So now I request Dr. H. Ramogan, sir, Honorary Secretary, IEA Coimbatore Local Chapter Center, to give a vote of thanks.
Thank you, ma'am. சாருடைய அந்த தேங்க்ஸ் ஸ்லைடில் வந்து என் உரையை கேட்ட அனைவருக்கும் நெஞ்சார்ந்த நன்றிகள்னு சொல்லியிருக்கிறாங்க. ஆக்சுவலி நாங்கள் தான் சார் நிறைய நன்றிகள் சொல்லணும் உங்களுக்கு. அண்ட் என்னுடைய ஒரு வேண்டுகோள் சார், ஏன்னா இன்றைய தலைமுறை, அதாவது யங் ஜெனரேஷன், அவங்களுக்கு இந்த கிளைமேட்டிக்கல் சேஞ்சஸ், அதாவது அவங்களுக்கு சேலஞ்சஸ் வந்து என்ன மாதிரி இருக்கும், ஆனா அவங்களுக்கு ஒரே ஒரு பாயிண்ட்ல வந்து ப்ளீஸ் டேக் கேர் ஆஃப் திஸ் பர்டிகுலர் ஸ்பெசிபிக் பாயிண்ட், அப்படி அதாவது ஒரு பாயிண்ட் சொல்றதுக்கு விரும்புறீங்களா சார்? என்ன சொல்லலாம் சார்?
You have to otherwise, if not otherwise னு ஒரு வார்த்தை உண்டு ஆங்கிலத்துல.
சொல்லுங்க சார்.
அதுதான்.
ஓகே சார். சார், தேங்க்யூ லாட் சார். எங்களுடைய நெஞ்சார்ந்த நன்றிகள் உங்களுக்கு. குட் ஈவினிங் டு ஆல் ஆஃப் யூ, everyone. It is an immense pleasure for me to deliver the vote of thanks. First of all, I thank our chairman, Dr. P.R. Nadarajan, for his welcome address. Thank you, sir. We thank Dr. G. Anusha, ma'am, Professor and Head, Department of Civil Engineering, KPR Institute of Engineering and Technology, for the presidential address. Thank you, ma'am. We thank Dr. A.K. Priya, Associate Professor, Department of Civil Engineering, KPR Institute of Technology, Coimbatore, who is the key person for organizing this program. Thank you, ma'am. We thank today's chief guest, Dr. S.R. Ramanan, former Director, Area Cyclone Warning Center, Regional Meteorological Center, Chennai, for his highly informative speech on climatic change and challenges. Dear sir, we thank for your excellent and wonderful session. எங்களுடைய நெஞ்சார்ந்த நன்றிகள் சார் உங்களுக்கு.
Thank you, sir.
We thank the principal and the management of KPR Institute of Technology for providing platform for this excellent program. We thank all the invitees, all the faculty members of KPR Institute of Technology, Coimbatore, all the participants, and all the student friends for their valuable presence. Finally, we thank one and all. சாருடைய சார்பாக நானும் எல்லாருக்கும் நன்றிகள் சொல்றேன். Thank you.
Thank you.
Thank you, sir. We formally wind this session. Department of Civil Engineering, KPR Institute of Engineering and Technology, in association with the Institution of Engineers. Once again, I thank all for actively participating for this webinar. Special thanks to Chairman Sir, IEI Chapter, as well Secretary Sir, for giving this opportunity for us to organize this event, and special thanks to Dr. Ramanan Sir for accepting our invitation for this lecture. Thank you very much, sir. We formally close this session.